I would now like to turn today's webinar over to Mr. Brad Schulteis, Senior AWS Architect. Please go ahead.
Thank you. So as mentioned, I'm a senior AWS architect. I work for Rackspace. I've been at Rackspace for about 15 months. I started basically when we launched our managed AWS capabilities last year at reInvent. Prior to working at Rackspace, I worked for AWS directly as a senior AWS solutions architect. And I also have worked for the US government for a number of years in the past. So this webinar, Focus on Governance, has a lot of different meanings to me. I've lived this, I've read this for a long time, and being focused almost exclusively on AWS technologies for the past 4 to 5 years. I have a lot of experience with seeing the transformation that's occurred in AWS, where it was kind of a toe in the water at first to kind of wholesale adoption by large enterprises. And one of the biggest concerns that I've heard throughout the years is governance or lack of governance in AWS. And today I hope I'm going to talk through why that's just not true, and actually why I believe the governance capabilities in AWS far exceed what IT enterprises have traditionally had. So for the agenda today, we're going to be talking about building for governance, breaking that up into 3 major facets within AWS. So we're going to be talking about detecting configuration changes in real time. And the key service there within AWS is AWS Config. We're also going to be talking about detecting security relevant events through audit logging. The capability there will be AWS CloudTrail. And then we're going to be talking about preventing unwanted changes. So the first 2 facets were kind of detective measures, with the last being more of a preventative measure. So actually blocking changes that we don't want to see in some of our environments. And we're going to be focusing there on CloudFormation policies, as well as IAM role policy configuration. So to level set, make sure we're all on the same page here. What is governance? What are we talking about here? So governance, basically how your organization is controlled. And a lot of time that takes an IT flavor. So it's really focused on ensuring that your organization IT enables corporate objectives. And that means placing a lot of control around how IT is used. So often we end up with that 3rd definition, which is sort of meant as a joke, but more often than not ends up being a reality for a lot of organizations, where we simply just say no to new IT requirements to avoid risk. All right, jumping in here, talking about detecting configuration changes in real time. So we mentioned that this is going to be the AWS Config service. This service, I think, is actually one of the most underutilized services, perhaps the most misunderstood service in the portfolio. It's actually very powerful, and it allows a great deal of governance control that prior to its existence, maybe didn't exist natively in the AWS toolset. But with the service available, it really provides a great deal of that governance visibility being paramount there. It's designed to give you visibility into the resources and help you in some of the following scenarios of resource administration, just seeing what you have, where it is, looking at auditing and compliance. So do you have a specific security compliance requirement, looking at what those requirements are and making sure that you are in fact complying with them. And also looking at troubleshooting configuration changes. So you make a change to the environment, things stop working, config can help you there, as well as using it as a security analysis tool. All right, looking at the first area here around resource administration, really the key enabler here is the ability to detect resource misconfiguration. So you have very fine-grained visibility into all the resources in AWS and how every one of these resources is configured down to the network interface level. So this has always been kind of a dream in the IT enterprise. We wanted these capabilities with on-prem infrastructure. We wanted this with virtualization. It's gotten easier over the years, but I'd say with this capability in AWS, the visibility is greatly increased. We're now able to see down to very specific configurations of your AWS resources, and using config, we can create rule sets. So there's two types of rules within AWS config. There's managed rules, and as of today, it's about 25 predefined rules that help you out of the box to get a start evaluating common needs. And then there's also custom rules. So the custom rules are actually Lambda functions that you can write yourself that contains evaluation logic that you can run against your resources to determine whether they're compliant or not. And when the config service detects that a resource violates any of the conditions in one of your rules, the resource is flagged as non-compliant, and a notification is sent using the simple notification service, SNS. And that can be, you can use basically any of the capabilities of SNS. That can be a push notification to your phone, that can be an email, that can be an integration with a webhook of another capability. So here's an example of using one of these config rules, actually one of the managed rule sets called desired instance type. Here we've configured a rule to look in our dev environment and see that we're only using T2 instance types. So we want to keep our costs low in our dev environment, but we still want to give autonomy and freedom to our developers. We're going to let them deploy things, but we're going to say that they should only be using the T2 Nano and the T2 Micro, and we're going to use config to validate that all of our resources do comply with that policy. So this is what the policy will actually look like. This is the AWS CLI output for describing this rule. So when we've applied this to our dev environment, anytime someone deploys something that's not compliant, we'll be able to flag that immediately and determine what that course of action is next. The next area is around auditing and compliance. So here we're going to ensure compliance with our corporate policies and best practices. It also gives us an ability to see historical configurations of all of our resources. Here an example, let's say you work in the healthcare industry and you're bound by HIPAA regulations and you're using AWS. That means that when you deploy a EC2 instance that processes PHI data, protected health information data, that instance needs to be deployed on a dedicated instance. That's a requirement of your BAA with AWS or your service provider. So here we're going to use another managed rule, this desired instance tenancy, to check for the use of dedicated instances. Here we're going to change the scope a little bit. So the scope, if you notice towards the bottom, is tag-based. So we're going to evaluate all resources that are tagged with HIPAA equals true. If an instance is tagged with that tag, we're going to evaluate it against this rule, and we're going to look for dedicated instance. If it's not a dedicated instance, we're going to know about that immediately. So here is that rule, desired instance tenancy, as configured through the management console. So here we can see that the resources with tags HIPAA true. We've detected two instances that are flagged as such. One of them is compliant and the other is non-compliant. So here, from a visual perspective, we can see immediately that half of our infrastructure is not compliant with our HIPAA requirements. Here we can see another view from the EC2 management console. We launched this instance on December 6th at 2:21 p.m. And then about 4 minutes later, I received an email saying that, hey, somebody launched a instance that violates our rule for desired tenancy. So near real-time response is capable. So as soon as somebody launches this, I get the email. I can contact the leader of that organization and say, hey, it looks like somebody deployed something. Or again, this is an SNS feed, so this could feed directly into some other tool where you could actually maybe set up a Lambda job to lock down that resource and remove all networking capabilities until you determine whether that instance was flagged improperly or deployed improperly. Another useful area is around managing and troubleshooting. So we all know this, a change in the configuration of one resource might have a cascading effect to take down your entire application. hey, it worked in the test environment, I deployed to production, it doesn't work. We've all experienced that. Using config, we have the ability to go back in time, see what changes were made to the production environment, which change potentially broke this deployment, and just revert to that known good state. The last area I'll focus on around the use of the config service is for security analysis. So this is a really powerful tool for security analysis. It allows us to do snapshot configuration views. Basically, every time a change is made in AWS, that is cataloged as a new change, and we see that in a timeline history for every single resource. So some very specific examples here, security groups. We're going to be able to look back in time at all of our security groups and all of their configurations over time as that security group has existed, as well as all of the uses of that security group. So we can see that the security group that allows SSH from the world typically isn't applied to any resources, but maybe somebody applied it temporarily to get access to a specific instance. That change is going to be captured as it's made. So you actually have two events in the timeline, one to change it to include that instance, one to change it to remove that instance. Another good use of this is for IAM policies. So you can see this user is typically part of the dev group, but somehow he obtained access to the production environment. If you go interrogate his policy today, it looks fine. He has only access to dev resources. But if you go back in time and look at what policies were attached to him, you can see for a brief period of time, maybe he was attached to the production policy inadvertently, and that gave him the access that he shouldn't have had. Here's another very specific example. Your CISO gives you a call, says, hey, December 6th, somewhere around 3:50 p.m., we had a security breach. We don't understand how it happened. Everything's properly configured. Everything's locked down. Our lead AWS guy said, hey, the security groups are all configured to not allow any external access, period. There's no way that somebody should have been able to get into that from the outside. So, all right, before config, how would you go about seeing this type of configuration change? Well, you'd have to have some sort of third-party tool, or maybe you didn't capture it at all. But with config, it's easy as going into the timeline history and seeing that, all right, on December 6th at 3:46 p.m., somebody changed the security group on the affected instance to add a specific IP address. So we opened up all access from that IP address, and then we can see about 5 minutes later, changed it back to nothing. So it covered their tracks, allowed 5-minute window where somebody was able to exfiltrate data, and now we can see how that actually occurred. If we were able to scroll down in this window a little bit longer, we'd actually see the link to the CloudTrail relevant events with this. So we can interrogate it even further and see who made that change, where was it made from, and how was it made. So talking more about detecting those security relevant events in CloudTrail. CloudTrail is another one of the services where, you know, everyone's like, oh yeah, we'll choose CloudTrail, but then that's sort of where it ends. There's a lot of capabilities that exist in CloudTrail that make it very interesting from a security perspective. First of which is it's an immutable record of all AWS API calls, and it's immutable. We'll talk about more about the immutability of that in a minute. Essentially, it's a JSON object for every single API call that is saved to a predefined S3 location. And using this CloudTrail event, you can answer a lot of questions. You can say, who made this API call? When was it made? What was the API call? What resources were impacted? And where was it made from? So very powerful tool. So what exactly is a security relevant event? Well, this is going to depend on your organization. It's going to be different for every organization. It might even be different on a per application basis. One application might have substantially higher security requirements than another. But there's some very popular examples that seem to be almost universally applicable to most organizations. One of those is around the creation, deletion, or modification of security groups and VPCs. So if somebody's creating a new network, you probably want to know about that. You probably want some audit history of that. You might even want real-time notification of that. CloudTrail makes that very possible. Another common theme is changes to IAM or S3 bucket policies. So you've got these policies in place. The policies themselves shouldn't be changing unless they went through some sort of change control board. So we shouldn't see an event for a changed IAM policy without a corresponding event existing in some sort of configuration management database. Another common theme is failed logins or failed API calls. Here we can see potentially someone attempting to brute force our account, trying to get in through the console, see a bunch of failures over time, or maybe a misconfigured application that's trying to submit API calls beyond its scope. So these are things we can quickly determine using the CloudTrail service. And the last one seems fairly obvious, but launching, terminating, stopping, starting EC2 instances seems obvious, but just a few years ago, before AWS, using different technology, you may not have had any insight. Somebody may have turned on a new server in your data center, and you had no idea that that happened. Maybe you had port security on the network, but probably not. And it probably had a new server up and running, and no one was the wiser. Now we are able to see all of the events. So someone creates a new server, turns it on, all of that's logged. And we can see who did it, when they did it, look for correlated events in other security contexts. So here's an example of using the CloudTrail service from the AWS command line. Here we can use the Lookup Event API. So here we're going to look for console logins. I'm going to pass that as a parameter. And here, when we run this command, we see there's one console login, customer Brad. I've truncated the CloudTrail event itself because it's very long. It includes a lot of information, including source IP. So a lot of useful information in there, but this is just the overview of the event itself. By default, you're able to interface with the past 7 days worth of events in CloudTrail. The rest of the events are still stored in that S3 bucket, but they're not indexed through the CloudTrail service anymore. So we would encourage you to follow your policy guidance for audit logs and potentially use another service to further index older events if that's a requirement of your organization. So here's another example. Here we're going to look up a specific username, and we're going to look up root. So hopefully your organization has the policy that nobody should be using the root credentials. Nobody logs in with root. Nobody issues root commands. Hopefully it's locked away somewhere. So when we run this, we're surprised to see actually it was used. Authorized security group ingress. So somebody modified the security group inbound configuration. And actually this is the event corresponding to that breach. So somebody had root credential access. Something we're going to have to look into a bit further, but it probably points at some sort of insider threat. Here's another example. Here we're going to list all the events over the past 7 days where the resource type was EC2 instance. So we're going to see all of the actions that were taken on EC2 instances. So here we see 2 events. One was terminate instance. So we see that user customer Brad terminated this instance with the identifier listed there. And then we also see he ran some new instances. So run instances is actually the API used to create new instances. And here we'll see all of the details and parameters passed to that run instances command. So we'll see what AMI was used, what key pair was used, who did this, where did they do it from. Very powerful. So we mentioned that this is an immutable record. These are just text files, they're JSON objects dumped into S3. So on their own, they're not necessarily immutable. Someone can go in and modify those events. But there's a lot of ways we can mitigate that. So we mentioned that we can put it in whatever S3 bucket we want. That S3 bucket might exist outside of the account in which you're monitoring. So only the security team has access to that account. So the operations team is generating these events, but the events are actually stored in the security team's bucket. So nobody from the ops team can go in and view, delete, modify any of their audit logs. You can also play with the permissions of the bucket itself. So you can make it a write-only bucket. You could remove the ability to delete objects so that they're permanently in there, or update. There's no update functionality in S3, so you'd have to actually delete and replace. You can completely eliminate that possibility. You can turn on versioning, so even if a change is somehow made, you still have the previous version. And then there's also inherent CloudTrail capabilities. So within CloudTrail, we actually have the ability to enable log file validation. That will actually create a digest of all of the CloudTrail events, and then store that digest in a digest file in that bucket. So we can validate every single event and its signature against the signatures on record. So this is the command you actually use to enable that. Very simple. Once we turn it on, we now have access to a lot of different capabilities. So now we can run the validate logs command on our specific trail, in our specific region, from a specific time. And we can see that these digest files were all valid, the log files were all valid. This means that these log files were not changed. So we know that this is an immutable record. Nothing has occurred since that audit log was created. Here we'll see a little bit different. Now we run the same command. We actually see that one of these log files is invalid. It wasn't found. It's missing. So somebody actually deleted one of the log files. So 30 out of 31 are valid, but one is invalid because it's completely missing. So somebody was attempting to cover their tracks maybe. Maybe that guy that had the root credentials went in there and made the security group change, changed it back, and then deleted the events associated with that. Here we see, run the same command. Here the hash value doesn't match. So that means the log file was modified. So this guy thought he was a little bit more crafty. He's not going to delete the file. That might be too obvious. He's going to change what it said. So maybe he changed the username that he logged in with. Maybe he changed the source IP address in the log file. Thinks he's going to get away with it, but we now know that that was invalid. And we can then go and correlate those events with some other things around the same time and hopefully detect who's doing that nefarious action. Okay, so we talked about a lot of ways to detect these things as they occur or go back in time and see things that occurred in the past. But what about preventing those unwanted changes? This is actually where a lot of the really powerful capabilities exist. So we've had detective capabilities around security for a long time in traditional IT. But now we have real preventative measures that we can apply. Since we're getting to that infrastructure as code way of deploying things in AWS, we can really lock down the ability to do things and limit them to the things that need to be done to get the job done and nothing more. So the key components in preventing your unwanted changes, we're going to focus today on using CloudFormation stack policies, as well as properly configured role policies within Identity and Access Management, or IAM. The first thing we're talking about is these CloudFormation stack policies. These are additional policy documents, JSON documents, defining update actions that can be performed on specific resources. So these are designed as fail-safe mechanisms to prevent specific stack resources. So stack resources are anything that was deployed as a part of that CloudFormation stack. We're preventing those stack resources from being unintentionally updated or deleted during a stack update. So if you've used CloudFormation at all, you know that it can be a little bit tricky knowing exactly what's going to happen if I update something. You might just try adding a tag to your stack by updating the stack, and you end up deleting the entire stack and redeploying it because of the way it was configured. That happens, and that is a very bad scenario in a production environment. So what we do is we write these stack policies that prevent that sort of unintended action. If we know that an action is going to result in completely deleting the production database and redeploying it, we probably want to prevent that through the use of a stack policy. because that's going to prevent these otherwise allowed updates. By default, all update actions are allowed on all resources in that stack if you have the correct permissions. So they might be a legitimate system administrator with the ability to delete the production database, but if they're just adding a tag to the production database, you don't want to delete that database. So we're going to apply the stack policy so that even if they have the permissions to do it, it doesn't actually allow it until you apply a override policy at the time in which you issue the command. And that's going to limit that blast radius of that action. So it's going to say you can't perform this action. It's important to note that this is not a replacement for proper IAM policies, so proper permission management for the users themselves. So this isn't going to prevent a developer that has access to everything coming in and destroying everything necessarily, but it may at least provide an additional step. He's got to issue the correct override policy. If he doesn't even know why or what that means, we may have prevented it in that case, but we still want to make sure that his role is properly scoped. All right, so this is an example of a stack policy. It's very simple. So this stack policy allows update on all resources created as a result of this stack, but it will deny the update of a production database resource. So everything else is fair game, but this is saying, hey, if you make updates to the stack and it's going to impact the production database, that's going to be denied unless you provide that override policy as a part of the command itself. This is really nice feature to have when you're managing production resources through CloudFormation, because you don't always know exactly what's going to happen. You don't want to impact your production database with an unintended delete and replace. The next thing we're going to talk about here is proper use of IAM. So this is key. We talk about identity and access management in security and enterprise IT for years. We talked about the property or the principle of least privilege. We talked about admin users versus regular users. We tried to build these capabilities. A lot of these were almost ahead of their time. It was very hard to lock these down because there are lots of disparate systems. It was hard to know what a user really needed to do his job because the APIs weren't there. The connectivity between the different capabilities wasn't there. But with AWS, we can really start to provide fine-grained access control and lock things down and really adhere to that principle of least privilege. So a developer only needs to access the development stacks, doesn't need access to the production account at all, doesn't need access to delete things. He just needs the ability to start and stop his instances. You can do that. You can say that this developer can access this account during normal business hours, and he can only use the EC2 service. That's completely possible today. As far as some other best practices, this one's really key. So root access. We saw before, nefarious actor was able to compromise our root credentials. That's a very big problem in AWS. So we would want to encourage all AWS consumers to eliminate all use of root. There's really almost no reason to use the root credentials. So for all of our customers, we actually delete all of the root key pairs. We enable multi-factor authentication. We store the password in a safe. You should implement all these as well. Maybe store the multi-factor token in another safe. Maybe send that safe to another country. Have it under lock and key, armed guards. There's very little reason you would ever use the root credentials, but it happens more often than you might think. You stand up this dev account real quick. It's been working on getting this account for 5 months. You finally have it, and you get the login credentials and go, okay, here you go, and go away now. So we've now got this development account. We think it's only used for development. People are using these root credentials. They're getting shared all over. One of the developers takes those root credentials, throws it into source code, checks the source code into GitHub. Now your root credentials for your account are sitting out on the internet. Anyone can go into GitHub, download these credentials, and have full, unrestricted access to your account. This happens very often. AWS will actually goes out to GitHub and other source code repositories and actively scans those repos for access keys and notifies the impacted customers that these access keys are compromised, stop using them. I actually worked with an organization that did exactly that. They had their root credentials stored in the source code. That was actually part of their operational capability, that when something got stood up, it used those credentials to generate resources. And I talked to them. I said, hey, you have these root credentials, and they're like, oh, that's okay. That's just our unimportant account. We don't really care what happens to that account. I was like, well, these are root credentials. They can do anything with that account. Like, yeah, we get that. Well, they can deploy hundreds of resources, and you're still getting the bill for that. Like, oh, I guess we hadn't really thought about that. So they stopped using those credentials, thankfully, deleted all the key pairs, and moved to IAM users. Definitely encourage you to use IAM users over the use of root if you must. But if you're using IAM users, we want to make sure that you have a strong password policy, that you're rotating credentials regularly, and that you're managing the permissions at the group level versus the user level. This will make it a little bit easier to manage. We actually advocate for using exclusively role-based access. So we don't have named users. We have roles assigned to specific permissions levels, and we use EC2 instance roles. So nobody even has credentials at all. Nobody logs in, period. If they have access to the EC2 instance, that instance takes actions on their behalf. And we're going to follow the permissions model of least privilege. So we want to make sure that we're doing that, but we're always including auditing. So CloudTrail is definitely going to be enabled across the board. And we're going to apply specific conditions. So IAM allows conditional responses. So these will further restrict privilege access with additional conditions. And those conditions really allow for next generation permissions models. So you can use, within IAM, you can use conditions, variables, resource level permissions. So you can apply very specific controls. You can have source IP constraints. You can have time constraints. You can limit things based on environment. So dev, UAT, prod might have all different constraints associated with it. You might have, you could build essentially one-way trust so that a developer can do something in the production account, but the production account can't do anything in the dev account, or essentially the opposite of that. You can allow specific templates and stack policies. You can lock down a user to only do certain things with certain stacks, or certain resource types within certain stacks. You can programmatically restrict access to those resource types, and really restrict what types of resources can be created at all. So we're getting to that nirvana state of governance where we can say that, we're using AWS, we're really only going to be using EC2 and RDS. We don't want anyone deploying any of the other services today. Create a policy for a role. Everyone authenticates into that role, and they can't do anything but those two services. We're okay with that today. Let them do whatever they want, but we're not comfortable with other services. Governance is okay. Everyone's happy. So here's an example of using a fairly simple policy. Here we have a junior developer. He has a read-only policy to look at the dev stacks. So this allows him to describe stacks, describe events, describe resources within CloudFormation, but only on resources that start with dev. So here we're using a wildcard. So anything that starts with dev, he can run these 4 APIs. That's fairly simple, straightforward example. Here's another example. So you have a software vendor coming in next week. You don't want to have to sit around and babysit them. You want them to get their work done. You want to give them full reign to do what they need to do, but nothing else. Well, with the IAM policy properly configured, you can say, well, this vendor policy allows full management of their vendor stack, and it expires next week. So they can come in, they can do whatever CloudFormation actions they need to with the stacks that start with vendor, They can do anything in EC2 as long as the resource tag managed by has vendor in it as well. But other than that, they're going to get denied. And they're also going to get denied even for the above action starting next week. So if we forget to revoke this policy and for some reason the vendor tries accessing this in 2 weeks, they will have none of these permissions any longer. Here's a very locked down example. Here we're going to limit deployments to one specific template. And that's all that this role is allowed to do. So here we're going to allow create stack as long as the template URL passed as a parameter matches this. So here we can upload this template to an S3 bucket in our account. We can lock it down so that nobody can modify that template. And then we can say that this is the only stack that's allowed to be launched via CloudFormation, period. It's also going to allow access to the subsequent resources created. So first of all, it's going to allow get that object from S3 because there's no default permissions to that object. We've locked it down, but this policy will allow access to get that template. It's also going to allow access to EC2, RDS, elastic load balancing, and auto scaling services because those 4 services are used within this template. And it's going to be able to do anything with those. But here we're going to deny the ability to do anything from the console and from the CLI. So essentially, we are saying that only CloudFormation launching this stack is allowed to interact with EC2, RDS, ELB, and auto scaling. So if this user logs in, grabs this policy in the management console, they won't be able to do anything in the management console. They won't be able to do anything in the CLI. Really, the only thing they can do is issue a create stack command with that URL. That's the only command they'll have access to. It will create all the necessary resources behind the scenes, but all other permissions will be locked down. It really gives you a lot of power from a governance perspective. You can create essentially pre-configured application constructs. You say that we have this type of Java application. We want anyone to be able to deploy it, but we don't want anyone to be able to manipulate it other than that. Using policies like this will really enable that. So with that, that is all of the information we have to provide for you. I would like to leave quite a bit of time for questions if we have any from any of the attendees. Okay, we have a couple questions here. So the first question is, do I have to use all these tools at the same time? So no, you don't have to use, really, I mean, that's the beauty of AWS. You don't have to do anything. You don't have to use any of these tools. We'd encourage you to use these tools, but you can use them individually. You can use them in conjunction with one another, and you're able to do a lot of things with these tools in concert, but they're all equally powerful without integration with the other tools. Next question is, how are those files being edited? I think that question is around the CloudFormation templates themselves. CloudFormation templates are just essentially JSON objects. So a JSON editor, a text editor will work, but JSON is a little finicky. You miss a comma and the whole thing fails. So you probably want to use a legitimate JSON editor to create the templates. There's also third-party tools that will generate CloudFormation templates for you based on some inputs. There's a lot of different ways to do it. I created all these with VI actually, but you don't have to do that. There's a lot of different options out there. Another question was, are all the government's tools presented available in all regions? I'd say for the most part, the tools we talked about here are available in most, if not all regions. Every service you will need to verify whether it's available in the region, but the IAM and the ability to use role policy definitely available in all regions. And I don't think there's any capabilities we talked about that were region specific. IAM is actually a global service. Another question was, can I phase these tools in. Yeah, again, I mean, these tools are up to you to consume in whatever way you want to. So you can just use them like I showed here via the CLI, kind of reactive. You can proactively set up automation using these tools. You can use the outputs of these tools in other tools. So we talked about CloudTrail generating these events. You might feed those events into some sort of anomaly detection engine, because maybe an individual event on its own doesn't really mean anything. But in the context of normal operating procedures, launching 10 instances at midnight on a Saturday might be a complete anomaly. So we would probably want some sort of tool to detect that. So that's something you definitely can do. The question was, in my opinion, the easiest tool to implement to increase my governance stance. That's a tough one. I would say CloudTrail, just go turn it on. That's pretty easy to do. But then you have to actually have a process to go in and evaluate those things or set up the proactive notifications. So that might be a little bit more complicated. Config is actually pretty easy to set up. But again, you're going to have to take action to go in and evaluate these things over time. I'd say setting up the out-of-the-box managed rules for a couple of things that you know you need to protect against, and just setting up email events to get started is actually pretty quick and pretty powerful. So if you're bound by HIPAA requirements and you know you need to be on dedicated instances, you can go create that rule in a matter of minutes, set up the email notifications, and learn almost immediately about non-compliant resources. I'd say properly configured policies in IAM is probably the best place to start. You really need to start with identity management and access and permissions up front. Scope things down to their least privilege, and that's going to provide you protective measures. You don't have to go in and see, you know, why was Jimmy doing this at midnight? Well, he doesn't have the ability to do anything at midnight, so it's not a problem. Any last questions? Okay, well, with that, I think we will wrap it up. Thank you for attending today, and don't forget to check us out on rackspace.com.